This is Epidemic miniseries episode 4, focusing on controlling epidemics. Last video we saw how an outbreak might die out after passing the epidemic peak, but this can still involve quite a lot of people getting sick, which really isn't ideal. We might not be able to prevent the disease arriving, but is there anything we can do to control the number of people who get the disease? Thinking back on our new disease, Disease X, if the R number, so the average number of new cases caused by one infectious person, is greater than 1, then Disease X will take off and cause an epidemic in the city. In this case, city officials may want to introduce control measures to limit the spread of disease and the impact on the health of the population. One method of controlling a disease is vaccination. The higher the R number, the bigger the potential outbreak, and the more people in the city will need to be vaccinated. Let's look at a couple of examples to demonstrate this. For R is equal to 2, let's imagine half of the population is vaccinated. If each person usually infects 2 people, but one of them is likely to be vaccinated, then each person only infects 1 new person on average. This means the effective value of the R number is 1. Therefore, if more than 1 in 2 people, or more than half of people are vaccinated, then we get R is less than 1 and the disease will die out. However, if R is equal to 10 and we have the same vaccination levels, so only half of people are still vaccinated, then each person on average infects 10 people and 5 of these people will be vaccinated. This means that each person infects 5 new people on average, and the effective R number is 5, which is definitely greater than 1. It works out as needing at least 9 in 10, or 90% of people to be vaccinated. We actually can get a formula for the percentage of people we need to vaccinate using the R number. This can be written as the proportion of people that need to be vaccinated is greater than 1 minus 1 over the R number. So if R is equal to 2, then we have 1 minus 1 over 2, which gives us 0.5 or 50% of people needing to be vaccinated. And if R is equal to 10, then we get 1 minus 1 over 10, which is 0.9 or 90% of people needing to be vaccinated. This calculation can be used to help city officials decide how many people they should aim to vaccinate. So now we've seen why outbreaks can seem to die out and how vaccination levels can be important for epidemic control. But what is it that makes diseases stick around in the longer term? Tune in to the next and final video to find out. Don't forget to like and subscribe, and thanks for tuning in to Epi with Emma.